Chapter 4.4 talks about the particle size of air pollutants, and the size of air pollutants can somewhat make a difference on their effectiveness, or I guess you could say their toxicity. So particulates, there you go, are solid and liquid droplets suspended in air. So they're stuck in the air, they stay in the air. Aerosols, which is another word, aerosol particles range from 1 nanometer all the way through about 10,000 nanometers. So a nanometer to 10,000 nanometers can be trillions of atoms. It can be some small amount of large molecules. Again, these remain suspended in the air, which is a pollutant, which is, that's what causes kind of like that smog look. It makes that where it's hazy, it's decreased visibility, it's hard to see. It also causes lung diseases when you breathe in. So if you're breathing in all these, dirty pollutants that are suspended in the air, it's going to affect your lungs. Interesting enough, these pollutants can even cause the earth to be cooled by reflecting sunlight. In fact, when several volcanoes erupted, like Mount St. Helens, for example, way back in the 1980s, the average global temperature actually went down that year because all the particles the volcano threw up into the air reflected some of the sunlight. In fact, that's one of the reasons why some scientists think the ice age was caused. Either massive volcano blew up so much ash in the air that it blocked out the sun, or a meteor hit the earth, in that case meteorite once it hits the earth, meteorite hit the earth and caused, again, a huge amount of dust and particles in the air to block out the sun. Some people go, well, I thought pollutants were supposed to cause global warming. What do you mean it's causing global cooling in this case? Well, it kind of depends on what the particles are doing here. But it's saying for these kinds of particles at this size that they can actually reflect some sunlight. And again, they can act as sites for chemical reactions as well. Now, where do these aerosols, these particulates, come from? They come from natural and anthropogenic sources. Now remember, anthropogenic, we talked about in the last part, means from human activity. It's humanly caused. How do we get rid of these particulates? How do we get rid of these aerosols? Well, nature can do it on its own, either by gravitational settling, that's with gravity pulling it down. The aerosol, these particulates get caught into rain, they get absorbed in rain, and it just falls down to the earth. But there's also physical means that humans can do. We can do filtration or centrifugal. I don't like the word centrifugation, but we can use centrifugal cylinders, centrifugal separation, chemical scrubbing, for example. That's what this stuff is here. One of the most effective ways to get rid of particulates is to use electrostatic removal. These are found in what look like smokestacks at factories. What this is dirty smoke or dirty gas goes into this smokestack. There's this long negatively charged rod that causes the gas to become negatively charged. The particles then get attracted to the positively charged walls. They get attracted to the positively charged walls, and then those particulates eventually just fall down and get collected down here. And then what's left over is this clean gas that comes out. So again, that's all there is for chapter 4.4.